Let's look at one of the limit theorems. It deals with the existence of a limit, whether the limit exists or not. What it says is for a two-sided limit to exist, the limit from the left and the limit from the right must be equal. What that means, if you are looking at the limit as x approaches c, the limit of f of x, and let's say the limit of f of x is a number L. Now this will happen if and only if, sometimes IFF is used, if and only if the limit as x approaches c from the negative side, the left hand side of f of x is equal to the limit as x approaches c from the positive or right hand side of f of x, and both of them are equal to L. Now, we say this is a two-sided limit because we're looking at a left hand side and a right hand side. Let's use this sketch of a graph to see what that is all about. You have this graph. Now, let us say that you have this number 1 right here, and you're approaching the limit of 1 towards 1, and you have this line. Let me use a straight line. It's a straight line graph, and you plot the graph and it goes towards 1. What this means is whatever graph this is, the fact is the limit as x approaches 1 from the negative side of f of x equals, and then whatever that is, let's say f of 1 is equal to, it goes up to say 3, alright? 3 is up here. The limit as it approaches 1, as x approaches 1, going from the left, that means you're going this way, is equal to 3. Now let's see what happens over here. You're plotting over this side, and what you have is the plot goes also right at the same point. So the limit as x approaches 1 from the positive side of f of x is also equal to 3. Then this limit exists, right? The limit actually exists. But let's make a few changes and imagine that the limit from the right hand side does not equal to the limit from the left. Say you're plotting the point and it comes up here, and let's say this point is at 4. Then what it means is that the limit as x approaches 1, that means you're going this direction from the positive side, that means from the left right hand side of f of x, is equal to 4. You see that? Now in this case, the limit at f of x equals 1 actually does not exist, right? They do not, the graph do not meet at the same point. There is a discontinuity, a jump from 3 up to 4, a sudden jump. You're going from the left and you end up at 3. You're going from the right and you end up at 4. As you approach -1, the limit is 3. As you approach 1 from the negative side, the limit is 3. As you approach 1 from the positive side, the limit is 4. So at x equal 1, the limit does not exist. We will look at this a bit more in another video.